Today we are going to start the sum of special terms of the series. Now we are already done with the AP and then GP. We have done everything, all the things that was required to do with AP and GP are done. Now we are going to start sum of the special terms of the series. Is it okay? So in this exercise we will have two types of questions. Before we go to the question, we will try to understand here, because we are given some result. We have some results to use in this exercise. Are you clear? And these are the results which we have to use in the given exercise. This notation is a Greek notation. It is read as sigma. It is read as sigma. In mathematics we call it as sum of, summation of. What? Sum of or summation of, anything. This represents mathematical operation of sum. Is this okay? So the meaning of this is, if I write x, that means sum of all the x. Sum of all the x. Is it okay?
Yes,
For how many x? For what values of x? That can be given to you later on. That can be given to you. Is it understood?
Yes, sir.
So the first result we have is sum of all the natural number. What is this? N. N is the natural number. Sum of all the natural number can be represented by this formula, by this result. N into n plus 1 divided by 2. Now when we try to find the sum of n natural number, n is any natural number. N is any number of natural number. So how many natural number you want? That is up to the question. In the question they will say maybe the sum of first 10 natural number, sum of 20 natural numbers. In that case the value of n will be given to you.
Yes,
And that same value of n can be used. Is it very clear?
Yes.
So this result will give you the sum of all the natural numbers. Second result is sum of the squares of first n natural number, and then the value will be n into n plus 1 into 2n plus 1 divided by 3. Likewise, we have the sum of cubes of first n natural number. And this is very simple, because if you remember this value, if you remember this result, then this result is simply the square of this result. If you square this result, you will get the result of the sum of cubes of first n natural number. Is it very clear? So basically we try to remember these two. Okay? And this has to be in your mind. I am not asking you to memorize it, but when we use it in this exercise for a few questions, automatically you will be able to remember. Okay? And after that, at a regular interval, you need to turn your notebook and then you can update yourself. You can revise yourself. Is it very clear?
Yes, sir.
So with these three results, we are going to enter into the exercise. And the first question here we have is, find the sum of n terms of the given series, whose nth term is this. May I have your attention, please? Find the sum of terms of the given series. This is a series given to you by means of nth term. This is nth term of a series. This is nth term of a series. And you know how do we write nth term of a series? We can write this as Tn is equal to this. This Tn represents the nth term of a series. So here we are given a series by a nth term, and we have to find the sum of all the terms of this series. Is it okay? So we are going to start this. We are going to find the sum of all the terms of this series. So the question is, we are going to find the sum of all the terms of this series. We will write this as summation of. We are going to find sum of all the terms of this series, and for sum of, we are using the notation sigma. Is this okay?
Yes, sir.
The same sigma will go with this right hand side also. And then same time, we can multiply this. Beforehand only we can multiply. This comes as n square plus 2n. And after this we can have the notation of summation. So we can write this as summation of n square plus 2n. After this we can open the bracket, and then this notation will go with both the terms. Is it okay?
Yes, sir.
And therefore this will be equal to summation of n square plus this 2 will come as the coefficient of summation, and then this is n. According to the given result, we have modified the question. We modified the question. so that we can use the results now. Now we can see here, this part became the sum of the square of the natural number, and we have the value of that result. Similarly, this is the sum of all the natural number. When it is only n, then we will take this as sum of natural number, and then we know what is the result of this. What is the value of it? This can be copied from this part. Are you getting me?
Yes, sir. Yes, sir.
So basically, in this question, when we are given the nth term, when we are given nth term of a series, we will do some kind of rectification in the equation. We will simplify it so that we get the terms in terms of n square and n cube. Because if the terms are in the form of n square and n cube, then we will be able to use these results because we have the answers of those all.
Yes, sir. Yes, sir.
So now this question is corrected. First of all, modify, and then final modification to modified question is this. After this, we are going to copy the result. Now it's a matter of only copy and paste. So summation of n square. Your answer is this much: n into n plus 1 into 2n plus 1. N into n plus 1 into 2n plus 1 divided by 6. Plus this 2 as it is, and then the result of this one. Summation of n natural. This is only n into n plus 1 divided by 2. Is it very clear?
Yes, sir.
Now, we need to reduce the fraction. We need to simplify the fraction, if it can be. This part cannot be done anything. We can't simplify this part, but this part can be simplified. This and this is cancelled. Am I right?
Yes, sir.
Is it okay?
Yes, sir.
After this, we will see the two terms and then try to find out if there is any common factor. In this and this, do you find any factor common? Do you see any factor common?
Yes, sir.
So we will take out those common factors. And those common factors are n and n plus 1. Is this the common factor?
Yes, sir.
So this is out and the remaining will be inside the bracket. This will become now 2n plus 1 divided by 6. Am I right?
Yes, sir.
From here you took out everything. So what is left? 1. When you have taken out everything as a common factor, then from this part we are left with only 1. Because when this is divided by this common factor, then what will remain? 1. The number divided by itself is always equal to 1. And now we will simplify the way we are simplifying the fraction number. I always tell you that if this is one is a fraction number and other is a whole number, then the other whole number also can be considered to be a fraction number. And now we will simplify. This comes n into n plus 1, and then LCM is 6. This is 2n plus 1 plus 6. Am I right? This is equal to n into n plus 1 into 2n plus 7 divided by 6. Is it okay?
Yes, sir.
And because all the factors are in the linear form. All the factors are in the linear form. So it cannot be simplified anymore, and that's how this is the answer. Is this okay?
Yes, sir.
If any of this factor was a quadratic, then further we could have simplified that part. Is this okay?
Yes, sir.
So we would like to see each and every part of this in the form of a linear form. In the linear form. Understood?
Yes, sir.
Thank you. The difference between this Roman number 3 and the question which we did right now is that the first question was given to us in the form of a factor. The first question is given to us in the form of a factor. This is given to us in the form of an expression. Is an expression. This is one single expression, and the previous question was in the form of double expression. Was in the form of double expression. The first term was a monomial, second term was binomial. Is this okay? So first question was a little more complicated than this one because the first question was given to us in the form of product. And we don't expect the question to be in the form of product. We want to have the question in the form of one single expression. One single expression. And that is why in the previous question we multiplied and we converted that into single expression. Do you remember?
Yes, sir.
So this question is even more handy than the first question. Is this okay?
Yes, sir.
Here, the terms are already in the form of n square, and n cube. That means we can directly use the results and simplify. Is it okay?
Yes, sir.
So we are going to find the sum of all the terms of that given series. So we will write this as sum of all the terms of this series, and then right this side also we do the same thing. We can have the summation notation for all the three terms separately. Can I have it?
Yes, sir.
So I can write this 4 in the front and then have sum of n cube plus 6 summation of n square plus 2 the summation of n. Here, one thing is very important. We need to understand that what is this? What is this? This is very important to understand. For your kind information, this is our general notation of a term of that given series. This is how we are representing a term of that given series. Right? There is a series which is not known to you, which is not visible to you. There is a series, and that series is represented by a single term. That series is any series can be represented by a single term. Any series can be represented by a single term. Example: 1, 3, 5, 7, 9, and so on. What is this? A sequence. It is a sequence. And this sequence, in place of writing this sequence, I can represent this whole sequence by a single term. By using nth term formula. By using nth term formula. That is the use of nth term. And one nth term, one single term can represent all the terms of that series. All the terms of series.
Yes, sir.
Understood?
Yes, sir.
So this Tn is equal to whatever it is the representative of that series. Is the representative of that series. One single term can represent the whole series. No, normally in the class we used to have a captain. And if there is any kind of meeting, then we call the captain. We don't call the whole class. Calling the whole class is very, very problematic. No?
Yes,
It's difficult. That is why we call a captain from each class, and then we talk to them, and then the class captain come back to the class and gives you the information. And that's the shortcut method of doing the big things. Am I right or not?
Yes, sir.
Am I right or not?
Yes, sir.
So similarly, why to write all the terms of the series is painful. No? Better if we can represent the whole series by a single term. And that is the job of this nth term. That is the task of this nth term. Have we got?
Yeah.
So how now hereafter, whenever this is given, please remember that these are the representative of the series. The representative of the series. Is this okay or not?
Yes, sir.
That means if I want to calculate a particular term of the series, I can have the value of n as that. And calculate, you will get that particular term of the series. If it means, suppose if I want the fifth term of this series, if I want fifth term of this series, then I can have the value of n as equal to 5. Calculate, you will get the fifth term. You want the seventh term, now you put n as equal to 7 and you calculate, you will get the seventh term. That is the beauty, that's the application of this nth term. Now have you understood that how this is giving you the whole series?
Yes, sir.
Is this okay?
Yes,
so
sir.
this one single term can represent the whole series, and you can calculate any particular term of that given series by using nth term. So I was telling you is that this single nth term can represent or can give you any term of that series. Is it okay?
Yes, sir.
And under this topic, whenever we have to calculate the sum of the special terms of the series, we want the nth term of the series. We always expect nth term of the series, and it's already given here. So we can directly put the value of n square, and n cube. We can calculate and get the sum of n terms of this given series. Is it okay?
Yes, sir.
So let us have it. This is 4, and this n cube value is n into n plus 1 into 2n plus 1 divided by 6. Sorry, This is n into n plus 1 divided by 2 whole square. Is it okay? Is it okay? Next one is plus 6 and this is n into n plus 1 2n plus 1 divided by 6 and this is plus 2 n into n plus 1 divided by 2. We wrote the value of all the given part, no?
Yes, sir.
After this, we will first try to simplify the numerator and the denominator, and only after that we will look for the common factor. Is it okay? So, these 2 will cancel, these 2. This 6 will cancel, this 6. Now, we have the square of this whole thing. That means this 2 will turn into 4. And outside we have 4. So, this 2 also will be cancelled, no?
Yes, sir.
Fine. Okay, now after this, here we have the square of this whole thing. Then we have this term and then this term. Look at all these 3 terms and tell me if you find anything common.
Yes, sir.
What is common factor?
N into n plus 1.
N into n plus 1. So we will take it out. So n into n plus 1 is out. From here still you get the same item, no? Because it is square. So 1 is out and 1 will be in. So this is n into n plus 1. From here you are getting only 2n plus 1. So plus 2n plus 1. Am I right? And then from here you get how much? Only 1. Because this whole thing came out. So this whole thing is divided by itself. The result will be 1. Is it okay? Now after this is n into n plus 1. And now we will multiply this. It comes as n square plus n plus 2n plus 1 plus 1, 2. Again this part item, no? So they will be added and therefore n into n plus 1 into n square plus 3n plus 2. We got this answer. Can we accept this answer? Can this answer be accepted? No. This is the linear. This is in the linear form. This part is also in the linear form. But this part of the answer is in the quadratic form. So this cannot be accepted. So what we'll do is, if we have quadratic part, then we will try to factorize. If this can be factorized, then. If it cannot be factorized, then what can we do? Then we will leave it as answer. Is this okay? But because this can be factorized, so we will factorize it more. And therefore, n into n plus 1 as it is, and this will be written as n square plus n plus 2n plus 2. This is factorized. The product of this and this is same as the product of the first and the last term, and the sum of these 2 is also equal to middle term. And therefore, n into n plus 1. Now from the first pair, we can take the common factor as n. Is it okay? So we get n plus 1, and then from another group we get 2 as a common factor, n plus 1. And therefore, it is equal to n into n plus 1, and from here you get n plus 1 again, and this is n plus 2. N plus 2. Can you see this answer? But here in this answer, what we notice is this n plus 1 and again n plus 1. So can we write these two parts in the form of exponents?
Yes, sir.
And that will become the present answer as n into n plus 1 whole square and then n plus 2. Is it understood?
Yes, sir.
Thank you. Now question number 2 is a type 2 question. Now if you compare this question with the previous question, it's completely different. Before we had the question in the form of nth term. The first question we had in terms of nth term. Now we have question in the form of series. Now we have question in the form of series. So it's completely different, right?
Yes.
Isn't it?
Yes, sir.
Our expectation is that the question should be in the form of nth term. We always expect the question to be in the nth term. Then it is easy for us because we have the results. If the questions are in the nth term form, only then we are able to use the result and solve the question. Is it okay?
Yes, sir.
It means by any means we want that nth term. We want nth term. In this question, we are given it in terms of series. Is it okay? Not only that, series means 3, 5, 7, 9, 11, and so on. We then call it as series. We call it as series. Now, this is a series. This is in AP. This is in AP. Now you look at your upper series. Then that series looks different from this given series. Isn't it?
Yes, sir.
This is very easy, and then we can easily understand how to work on it.
Yes, sir.
Whereas the given question is little complicated. Of course, that question is also in the form of a series, but it is multiple series. It is multiple series. We have more than one series at a time. That means this given question is a combination of two series. And these two series are given to us in the form of a product. So, what we will do here is, let me have your attention here. So, I was telling you is that this is a combination of series. If there is only one series, then we can easily calculate the nth term of that series. If I ask you to calculate the nth term of the series, it's very easy because your last term is n term. You want to calculate the nth term. That means the value of n will be n only. And the first term is 3, and the common difference will be the difference of these two. So like that we can write Pn is equal to 3 plus n minus 1 into d, that is 2. And then that's how 3 plus 2n minus 2, and this is equal to 2n plus 1. And this became your nth term of that series, of this series. How easy to calculate if the series is given?
Yes, sir.
Is it okay or not?
Yes, sir.
But in this question, we have a combination of series. This is set of two series. This one question is set of two series. Now, since we have two series, so we need to have nth term formula for each series. That's the first thing. Since it is a combination of two series, so we will have nth term for both the series. Number one. Number two, all the series, both the series are given to you in the form of product. Both the series are given to you in the form of product. So after calculating the nth term, we will write the nth term also in the form of product, and then finally we can have the nth term of this compound series. The first series is, see here, where is the first series? For the first series, we will take the first term of each pair.
Yes, sir.
To create the first series, to visualize the first series, we will just pick the first term of each pair. That means this, and so on. Like this. If you take all this underlying number, then this will give you one series. Now when it is underlined, it's very easy for you to know what is the first term and what will be the common difference. So the way I calculated this question, you will be able to create the nth term for that given series. No?
Yes, sir.
Likewise, after calculating the nth term for the first series, we will then calculate nth term of the another series, which is given to you in the form of product. And another series is 5, 7, 9, and so on. So this set will give you another nth term. So we are going to calculate the nth term for both the series. Is it okay?
Yes, sir.
So I am going to calculate the first nth term for the first series, and for that the formula is a plus n minus 1 into d, because when you see the term 3, 5, 7, then you will understand that this is given in AP. So we will use the nth term formula for AP. So a plus n minus 1 into d. A is the first term, that is 3 plus n minus 1 into d. The common difference is 2. And and therefore this is 3 plus 2n minus 2, and this is finally 2n plus 1. So you got now nth term formula for the first series with first term of each pair. Am I understood?
Yes, sir.
Now likewise we are going to calculate the nth term for the another series with the second term of each pair. So that will be now, and because both the names are same, no, I am finding little confusion. So for my convenience I will mark it as P and dash, so that I will know that this is the nth term for my second series and this is the nth term for my first series. Is it okay?
Yes, sir.
And therefore the first one is this, so 5 plus n minus 1 into d. Again this also d is common difference 2 only. So this is 5 plus 2n minus 2 is equal to 2n plus 3. So finally we got nth term for both the series, no?
Yes, sir.
And we know that both the series are in the product form. That means to get the real nth term formula, we have to have the product of these two nth terms. Is this okay?
Yes,
so
sir.
your actual nth term can be represented as capital Tn. Can I?
Yes.
And then this will be the product of these two. That means the product of these two. So it will be 2n plus 1 into 2n plus 3. Now this is again in the factor form. Same as question number 1. We want this to be in the single quadratic form. Single algebraic form. Not quadratic, single algebraic form. So we'll simplify. This will become 4n square, 6n, 2n, 8n, and then plus 3. We got nth term of that compound series. This is final nth term of your compound series. After this, we can now calculate it. Is it okay?
Yes, sir.
Again, before I start, I will tell you that this is the nth term of a given series. Means by using this, you can calculate any term. You can calculate any term. Or every term can be calculated by using this. Is it okay?
Yes, sir.
If you are calculating the first term of the series, this whole thing will be used. When you are calculating second term of the series, this whole thing will be used. You are calculating third term or fourth term or fifth term of the series, this and this. Every time the same thing is going to repeat. Understood or not?
Yes, sir.
Since this is a constant and this is also going to repeat with the whole equation, and every time this part also is going to be repeated. Okay? So that is why we have to keep this in mind. I'm going to tell you something. After this, I'm going to find the sum. So we'll say sum of Pn is equal to sum of all this. So we'll write here 4 out, summation of n square, 8 out, summation of n, and then this is just a constant. With this constant, we cannot use the sum of because it's just a number, right? So, but this is repeating for every term, no? And we are going to calculate sum of n terms. That means this will be 3n. If you ever have constant, just a constant, with that constant, please be mindful to write n. To write n. Is it okay?
Yes, sir.
After this, nothing. Just put the value. So 4 into n plus 1 into 2n plus 1 divided by 6. This is 8 into n plus 1 divided by 2, and this is as it is 3n. Is it okay? Now we simplify. This 2 4s are 8. This 2 2s are, and this 2 3s are. Simplify, no?
Yes.
After this, we will see if there is any like term. Do you find any like term?
Yes, sir.
What is that?
N.
Only n. From starting till the end. There is only n, no?
Yes, sir.
So only n is the common factor. Keep your eyes open. N is out. Now rest we are going to write. Now this n is out. So here we will have 2 into this into this. So can I multiply these two together?
Yes, sir.
2n plus 2. And this is 2n plus 1 divided by 3. This will be. Can I multiply this whole thing?
Yes.
N into n?
More.
Oh no, n is already out. No? from here we get only 3. Is it alright? Next step, n out. Now we are going to multiply. This is 4n square. This is 2n and this is 4n. 6n plus 2 divided by 3. And this is 4n plus 4 plus 3, 7. Is it okay? Now because this is a fraction number, can we consider this also to be a fraction number?
Yes, sir.
Now, next step. n into 4n square plus 6n plus 2. Okay? And the LCM of this both will be 3. So now this will be multiplied by this one. No?
Yes.
So this will become 12 n and then 7 3 the 21. And then whole divided by 3. This is now n 4n square 6n plus 12n 18n and then 21 plus 2 23 divided by 3. Now here in this part, this is a quadratic. What normally we have done is, whenever it is quadratic, we try to factorize it. Is it okay?
Yes.
But we factorize if it is possible. In this case, it is not possible. So this is your final answer. Have you understood?
Yes, sir.
Thank you.